Often in thermodynamics, you'll hear us say, use Hess's law to calculate the delta H of that, or the change in enthalpy. You can easily get it with Hess's law. So what do we mean when we say Hess's law? Hess's law is really a simple concept. The idea is the change in an overall process from state one to your final state. You're going to start here, you're going to end here. Sometimes that straight transition from start to finish is difficult to do by itself because it's just too complicated. But if you break it up into steps, you go from starting point 1 and you have an intermediate step 2, step 3, step 4. Doesn't matter how many steps, you can break it up into what we call simple steps, and as long as you know the delta H, or the enthalpy change for each step, you can then sum all the steps up and get the overall change for the bigger change. And we do this constantly in thermodynamics. And it really goes back to the beauty of state functions. State functions are totally path independent. And because of that, it allows us to choose the easiest path to get from state 1 to the final state. And what we tend to do is we tend to pick paths that we know how to calculate. So when we add them all up, we get the overall delta H. So how do we write it? It's pretty simple. We write that the delta H total is equal to delta H1 plus delta H2 plus delta H3, etc., etc. However many steps you got, you add them together. For us chemists, we're often adding reactions together. And so you just stack a bunch of reactions and you add them up, cancel what's alike on each side, just like you do in algebra, and do the same thing with the delta H's. The only thing I would also point out about Hess's law is sometimes we're given reactions and they're not really pointing the right way. They're going the wrong way. We need it to go that way, but it's shown this way. So how do you handle that? Well, you do what I call a reaction flip. You just simply take your reactants and your products and you just flip that reaction where now your products are over here and your reactants over here, and you change your arrow. Thermodynamically, the states are still the same. It's still the same substance here and here, you just change their positions. So the beauty of that flip is the delta H numerically is exactly the same, but the sign is different. So if you had a positive delta H, you flip it, now it's a negative delta H. So that is a simple idea so that you can manipulate reactions by flipping them and adding them together. So you already know how to flip a reaction, change the sign. The last thing is sometimes the amounts aren't quite right. Maybe you've got 1 mole of water to start with, but you really need 2. So the way you handle that is you scale the whole reaction. You take everything in the reaction and double it. Now you have 2 moles of water. Whatever you have as products, it works out. You double each one of them from whatever they were. The delta H you also double because you're doing twice as much stuff, you have twice as much energy involved. And that's an extensive property, meaning we are quantifying the amount we do. So if we do twice as much, you get twice as much energy change. If you do 3 times as much, you get 3 times. So now we're able to start taking a series of reactions and flipping them, doubling them, halving them, and as long as we do the accounting work on the delta H's, we can sum them up and get the overall delta H of change. And that is what we mean by Hess's law. One last thing. Even though we call this Hess's law and it's all about delta H, it works for every state function there is. All state functions work this way. It's just that with delta H, it got the name. It got Hess's law stamped on it. It will work for delta G, it will work for delta S, it will work for delta E. Heck, it'll even work for pressure and volume changes. It works for every state function. So remember, Hess's law is the poster child for all state function overall changes. Do the steps and get the overall change. That's the whole idea behind Hess's law, and you're going to use it a lot.